Hello students, welcome back to my channel once again. This video today I am going to explain the next topic under active methylene compounds. If you remember in the previous video we started the applications of ACETIC ester under which we have completed preparation of monocarboxylic acids. Hope you have watched that video, completed writing notes and also practicing. Okay, no worries if you haven't watched yet. Please watch the video and kindly note down the preparation of monocarboxylic acids from ACETIC ester, which I have given a very easy method of doing. Okay, please kindly note down students. And also if anybody who is watching for the first time, please do subscribe the channel and also like the video so that it will be reached to number of students. And also please share it with your friends. Okay, ready for the next topic students. So after monocarboxylic we have the application of acetoacetic ester, preparation of dicarboxylic acids. You know, monocarboxylic means it has only one COOH group, whereas dicarboxylic acids, they contain two COOH groups. Okay, kindly open your notebook students. Ready with the pen? Right. So put the side heading, preparation of dicarboxylic acids, under which the first example I have taken is succinic acid. Kindly don't write spelling mistakes students. SUCCINIC, succinic acid. Now what is the structure or what is the formula of succinic acid? See, you can find two COOH groups and this is CH2COOH, CH2COOH. Total 1, 2, 3, 4 carbons are there and 2 COOH groups. So this compound is called as succinic acid. Okay, so now the starting compound is acetoacetic ester. So now by this time you must be knowing the formula of acetoacetic ester. What is it students? CH3, C double bond O, CH2, C double bond O, C2H5. This is the active methylene group as it is present in between two high electronegative groups. Okay. Now treating this acetoacetic ester with NaOC2H5. What is NaOC2H5? Sodium ethoxide. So you know when this is treated with sodium ethoxide, OC2H5 minus, that is the ethoxide ion, takes up one of the hydrogens from active methylene group. Okay, so OC2H5 minus plus H plus gives C2H5OH. So minus C2H5OH, that means this will be coming out. In the place of hydrogen, sodium will be replacing the place of hydrogen. So what is the next compound? Look here, CH3, C double bond O, CH. Here what did I write students? Yes, in the place of hydrogen, here comes sodium, C double bond O, C2H5. Okay, so those who have watched the previous video, you will be knowing there will be hydrolysis, that is acidic hydrolysis taking place, and the reagent that is used for this acidic hydrolysis is concentrated alcoholic KOH. Okay, so concentrated alcoholic KOH, when this is used, when hydrolysis takes place, look at the compound. This is the compound which is to be prepared, right? Now, so from hydrolysis, when concentrated alcoholic KOH is used, this part, this CH2COH part will be obtained, and whichever group is attached to this carbon, we need to introduce this group. Okay, before hydrolysis. Fine. So here after Na is replacing hydrogen in the active methylene group, the group or the compound or the reagent that is to be used here is ClCH2COH. Anybody who knows the name of this compound students? Okay, if you know, well and good. If you don't know also, well and good, I will tell you. If this is CH3COOH called as acetic acid, but in the place of one hydrogen there is chlorine. So chloroacetic acid. Fine, students. So there is Na over here, there is Cl over here. So Na and Cl will be coming out as NaCl. So write down below the arrow minus NaCl. So when Cl is going away from this compound, what is remaining here? CH2COOH. Here the bond is vacant now, here the bond is vacant. So this C and this C will be binding up together. So this CH2COOH will come near this carbon. So the next compound that is forming is CH3, C double bond O, CH, CH2COOH, C double bond O, C2H5. So whichever group is required here, that group is being introduced. Fine. So now almost we have come to the end. So now write down here, put an arrow and write the reagent concentrated alcoholic KOH. You know how hydrolysis takes place as I explained in the previous video. Here you can see the bond between oxygen and carbon breaks up HOH. Next here this bond breaks up HOH. Okay, so CH3COOH goes out, C2H5OH goes out. What remains? CH2COOH, CH2COOH. Okay, got it? So that is our succinic acid. This is one method of preparing succinic acid from acetoacetic ester. Okay. And there is also one more method which is used for the next higher compounds. That also I have shown here, students. So I have written or. This is any one method you can use for the preparation of succinic acid. But the method that I am going to show you now, this is used for the preparation of next higher dicarboxylic acids. So what did we do here? Taken two molecules of acetoacetic ester. This one is one acetoacetic ester. This is another acetoacetic ester. And treated with 2 sodium ethoxide, 2NaOC2H5. Okay. So one hydrogen from this group, one hydrogen from this group will be coming out or will be joining with 2 ethoxide ions and will be coming out as 2C2H5OH. So minus 2C2H5OH. Now one hydrogen here will be replaced by one sodium. One hydrogen here will be replaced by another sodium. Come, let us see the next compound. CH3, C double bond O, CHNA, C double bond O, OC2H5. Next, CH3, C double bond O, CHNA, C double bond O, OC2H5. Okay, next what to add here? Now these two should be joined together. So in order to join these two, what did we add here? Look here, put an arrow and add I2. Okay, so when you are adding I2, what happens? 1 Na, 1 I, 1 Na, 1 I. So comes out as 2 NaI. Sodium iodide will be coming out 2 molecules of NaI. Okay, now this is empty here, this is empty here. So when these two sodiums are going out, this carbon and this carbon will be bonded. Okay, and there will be a bond forming between this carbon and this carbon. So excited to see the next compound? Yes. CH3, C double bond O. Look here, students. CH3, C double bond O, CH, C double bond O, OC2H5. Next, CH3, C double bond O, CH, C double bond O, OC2H5. Look here, now there is a bond between this carbon and this carbon. Okay, now this is joined together. These two are joined together now. Next comes the, the reagent? Concentrated alcoholic KOH. AlCKOH, concentrated alcoholic KOH. You know, when this reagent is added, hydrolysis will be taking place. Same here, the bond will be broken. Here the bond will be broken. Here this bond will be broken. This bond will be broken. Okay. So what happens here? Look here, students. Here the bond is broken, HOH. 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 OH. Okay. Now, one CH3COOH, second CH3COOH. So, total minus 2 CH3COOH. Next, one C2H5OH, second C2H5OH, minus 2 C2H5OH. What is remaining inside? This is the main compound that we are getting. So, CH2COOH. Next, CH2COOH. That is our succinic acid. Okay, students. So, this is how we prepare succinic acid following this method, that is taking 2 molecules of acetoacetic ester. Fine. Shall we move on to the next compound, students? Number 2, glutaric acid. GLUTARIC, glutaric acid. CH2COOH, CH2COOH. Now there is one CH2 group extra. Total how many carbons? 1, 2, 3, 4, 5 carbons. Succinic acid only 4. Okay. Now, so this portion can be, we can get from hydrolysis. Now this carbon is now having this group CH2, CH2, COOH. This group has to be introduced. So how to do? Chalo. Take 2 molecules of acetoacetic ester. The second method which we have followed for succinic acid, that is to be followed here also, students. So taking 2 molecules of acetoacetic ester, 2 NaOC2H5 minus 2 C2H5OH. Okay, now I think you understood where from this C2H5OH is coming. OC2H5 minus H plus. OC2H5 minus H plus. Minus 2 C2H5OH. Now one hydrogen place is vacant, one hydrogen place is vacant. So here 1 Na, here 1 Na. Okay. Next, CH3, C double bond O, CH Na, C double bond O, OC2H5. Next, CH3, C double bond O, CH Na, C double bond OC2H. These two are separate, yet they are not joined. Okay. Now what is to be taken here? Previously for succinic acid, I2 is taken, but here what is to be taken? CH2I2. Do you know the name of this compound, students? CH2I2. What is CH for? Methylene. So, in the place of 2 hydrogens, there are 2 iodine atoms. So, CH2I2. Methylene iodide. Its name is methylene iodide. Okay. Now, what happens? Can you guess, students? So, 1I, 1 Na, 1 NaI, 1 I and 1 Na, second NaI. Okay. So, minus 2 NaI will be coming out. 2 molecules of sodium iodide. Okay. Now, what is remaining here? CH2. Okay. So, this CH2 will be coming in between this carbon and this carbon. So, CH, CH2, CH. Okay. These two will be joining now. Come, let us see the next compound. So, CH3, C double bond O, CH, C double bond O, OC2H5, CH3, C double bond O, CH. Look here. Between these 2 carbons, now there is a methylene group CH2, C double bond O, OC2H5. So, next is the final step. Concentrated alcoholic KOH. Hydrolysis will be taking place. So, I will show you, I will break the bonds and show you, students. Look here. This bond is broken, HOH. This bond is broken, HOH. Here this bond is broken, HOH. Here this bond is broken, HOH. Okay. So, you know, total minus 2 CH3COOH. Where are they coming from? Here 1 CH3COOH. Here another CH3COOH. Next, minus 2 C2H5OH. 1 C2H5OH, second C2H5OH. Okay. Now, what is remaining inside here? The main compound CH2COOH. CH2CH2COOH. Got it? That is our glutaric acid. Fine, students? Right. So, this compound has 5 carbons. Next dicarboxylic acid having 6 carbons. Number 3, write down adipic acid. Adipic acid. So this is CH2COOH, CH2, 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 COOH. Total how many carbons? 1, 2, 3, 4, 5, 6. Okay. So this you will be doing as homework. Try it, students. If you are not able to do, please post in the comment box so that I will make the video of preparation of adipic acid and post again so that it will be easy for you. Okay. And one clue or hint I will be giving here. The compound that is used before hydrolysis I will write here so that you can try on your own. So students, look here. This is ethylene iodide. CH2, CH2, I. Okay. So this is the compound, this is the reagent that is used before hydrolysis. So please try doing it, students, so that you will easily, you can easily learn preparation of dicarboxylic acids. Okay. Shall we move to the next compound? So we have 2 more in the syllabus, students. We completed dicarboxylic acids. Next we have preparation of ketoacids. Okay. Under this, the example is beta-keto-butyric acid. Okay. So what is this beta-keto-butyric acid? CH3, C double bond O, CH2, COOH. Beta-keto, this is the beta carbon. So beta-keto butyric acid. 4 carbons are there total. 1, 2, 3, 4. Fine. So how to prepare this from acetoacetic ester? To start with, take acetoacetic ester, CH3C double bond O, CH2, CO, C2H5. So starting initially, we know that NaOC2H5 is used. Okay, so one of the hydrogens from active methylene group and OC2H5 comes out as ethyl alcohol, and this H will be replaced by sodium. So the same I have written here, CH3 C double bond O, CHNA, C double bond O, OC2H5. Okay, so what is to be added now? Look here, CH2COOH. This can be obtained from hydrolysis, as you all know. Now what is the group attached to this carbon? C double bond O, CH3. So this group has to be introduced. Fine. So in order to introduce that group, the compound taken or added over here is CH3COCl acetyl chloride. So this Na and this Cl will be coming out as minus NaCl, and COCH3 will be bonding with this group will come and join this carbon over here. Okay. Next is CH3 C double bond O, CH, CO, CH3, C double bond O, O, C2H5. The final step is concentrated alcoholic KOH. Hydrolysis takes place. So here the bond breaks and minus C2H5OH. Here the bond breaks and minus CH3COOH, and the final compound is beta-keto-butyric acid, that is CH3 C double bond O, CH2COOH. Okay students, look here. I have shown you the hydrolysis part also. The final product is keto acid, that is beta-keto-butyric acid. Fine. Next application is, students, preparation of alpha-beta unsaturated acids. Okay. So alpha-beta unsaturated acids, we have the example crotonic acid, CROTONIC, crotonic acid. So I request you not to write spelling mistakes, students. Please kindly note down carefully. CROTONIC. What is this crotonic acid? CH3, CH double bond CH, COOH. It is an alpha-beta unsaturated acid. Alpha carbon, beta carbon, there is unsaturation. Hence this is alpha-beta unsaturated acid. We all know that on hydrolysis, we will be getting this group, students, CH, COOH. what is the extra group added over here to this carbon? CH3CH double bond. So this group has to be introduced in acetoacetic ester. Okay. So shall we do? Right. So taking acetoacetic ester, CH3C double bond O, CH2C double bond O, OC2H5. Here we are not adding NaOC2H5. We are adding over here acetaldehyde. CH3CHO is acetaldehyde in the presence of pyridine. Okay. So here I have written acetaldehyde, students, CH3C double bond O, H. So what it does in the presence of pyridine? So this oxygen and these two hydrogens will be coming out as water. See these two hydrogens and oxygen, H2O. Here write down minus H2O. Okay. So minus H2O write down here. Next what do we get? CH3 C double bond O, C. Now there are no hydrogen atoms here, but there is a group here, C double bond CH, CH3. Look here, students, these two hydrogens are removed, oxygen is removed. Here two bonds are vacant, two bonds are vacant. So this carbon and this carbon will be attached with a double bond. The same I have written here, C double bond CH, CH3, and this is same as usual, C double bond O, OC2H5. Next comes here concentrated alcoholic KOH. That is acidic hydrolysis. As you all know, minus acetic acid minus ethyl alcohol, we will be getting the final product. Hydrolysis takes place here, students, HOH. This bond breaks and HOH. CH3COH, C2H5OH coming out. Next, what is remaining here? CH3, CH, double bond, CH, COOH. That is nothing but crotonic acid. This is our compound. Okay. So here is the compound CH3CH double bond CH-COH. This is how we prepare crotonic acid, students. Second, alpha beta unsaturated acid. Example we have cinnamic acid, students. So what is cinnamic acid? C6H5, CH double bond CH, COH. What is the difference between crotonic acid and cinnamic acid? See, crotonic acid you can see here. Here there is methyl group, here there is phenyl group. Okay. So in order to prepare crotonic acid, what did we add? We added acetaldehyde. Can you guess what to add for the preparation of cinnamic acid? Instead of acetaldehyde, here cinnamic acid preparation, we use benzaldehyde in the presence of pyridine. Please kindly, this also you do it on your own, students. Here I will write what is to be added. Write down in brackets. So same process, C6H5 CHO in the presence of pyridine. Taking acetoacetic ester, here you will write C6H5, C double bond O, H, same water molecule will be removed, but there will be a C6H5 group over here. So by using benzaldehyde in the presence of pyridine, we can prepare cinnamic acid from acetoacetic ester. So this is all about today's video, students. So today I explained preparation of dicarboxylic acids. Fine, under which we covered dicarboxylic acids, keto, next preparation of keto acids, preparation of alpha beta unsaturated acids. Okay, so with this acidic hydrolysis under active methylene compounds is completed. So please kindly note down all these preparations in your notebook, students, and kindly prepare for your exams. And as I told you in the beginning, please, those who are watching for the first time, subscribe, and whoever has subscribed, please like the video so that it will be reached to a number of students. Okay, students, take care. Meet you in the next video with a new topic.